So we're going to start with Chapter 1, Section 2. The book titles it Applications in Modeling with Linear Equations. It's pretty much another term for what you know as word problems. So let's go ahead and start. I think there's about 4 we're going to do. So let's solve that's our objective. One objective is to solve applied problems or solving word problems. So here are some steps to help just general steps. First, you have to read the entire problem carefully. Take notes on what values are given and what quantity is being asked for. That's really important. Assign a variable name to the unknown quantity, such as x. If any of you are puzzle solvers, maybe you've done some more puzzle solving, I'm talking about jigsaw puzzles. I consider solving much of math, including solving problems, a jigsaw puzzle. You're giving a lot of pieces laid out, and to solve the problem, you start finding relationships between the pieces. That's especially true for solving applied problems or word problems. If you don't know what you're looking for, then there's no hope of succeeding. So that's really important that you first read the problem carefully, identify what is being asked for, and assign a variable, which we will always use as x, for that unknown quantity. So whenever possible, write a general, really general guiding equation that relates the concepts given. For example, if you were asked a question involving the total cost of an item, one such general equation could be the total price or the total cost is the total cost of all food items plus the cost of the tax. Use that general equation and the details that you later find out to help you put the pieces together. Draw a picture to help, or make a table when appropriate. We'll be doing both of those things. Using what you have in 2, meaning your guiding equation, break down parts of the guiding equation so as to include the unknown quantity x and the values given. 5, solve the equation when you have a linear equation with just one unknown value. That would be x. State the answer to the original problem in words. Number 7 is really important. Conceptually check that your answer seems right. If length is asked for, is your answer negative? Do we have such a thing as a negative length? Doesn't make sense. That's a key, a good hint that you've done something wrong. Here are some of the general guiding equations that we're going to be using. Speed is equal to distance over time. Now, speed is equal to distance over time is often, as a matter of fact, I was just watching old episodes of Jeopardy, and this very equation appeared. So that's often given this way. I think I'm good to go now. Speed is given by rate. R means speed. D is the distance. And time is denoted by a T. So speed, think about it, is miles per hour. So that's in scare quotes. So that tells you, did you see what I did there? I assigned an S for speed instead of an R. Sorry about that. R stands for speed. I like S better, but R is what they use. Is conceptually miles per hour. Miles is a measure of distance, An hour is a measure of time. So we have the equation R is equal to D over T. But now is when we immediately will start using other techniques. Solving for T, if you want to solve for T, you can multiply both sides by T, and that gives me R times T is equal to D. Because when I multiply both sides by T, that gives me T times R, or R times T. And the D times T divided by T just leaves D. So it's important that you're able to manipulate some of these general equations, like rate or speed is equal to distance over time. Because the unknown might very well be time, in which case you probably don't want it in the denominator. Another guiding equation is that the percent of a concentration times the quantity of that concentration. And here I say rate times quantity. Really it's just percentage, or that strength, is equal to the amount of pure substance present. And 2 is going to be interest is equal to principal times the interest rate times the time in years. So we have 4 and we're going to tackle all of them. You'll see 2 types of these on the exam, and so it's good to know how to do all of the different types. I haven't written the exam yet, so I have no idea what's going to be on there. So here's our first one. If the length of each side of a square is increased by 3 centimeters, the perimeter of the new square is 40 centimeters more than twice the length of each side of the original square. Find the dimensions of the original square. So X is going to be the dimensions of the original square. Now remember, a square is just a special type of a rectangle, which I'm attempting to draw right here. So what are the dimensions of a rectangle? The length times the width. But in a square, the length and the width are identical. So in the square, the length is equal to the width, and that's our unknown. So we just want to find the length of one side, and once we know the length of one side, that's going to be the dimensions of the original square. So let's start drawing a picture. So let's draw our original square. Just kind of eyeballing it here to the best of my abilities, which is certainly better than what I would do. So that's my original square. And our variable is going to be x, where x is equal to the length of one side. One side of what? Our original square. But what I'm going to do is I'm going to create another square. So the perimeter of the new, so if the length of each side of the square is increased by 3 centimeters. So what I'm going to do is I'm going to draw another square, with that one kind of dead in the center. And as it turns out, the length of each side is going to be increased by 3 centimeters. That means the length of this square up here side is going to be x plus 3. Of course, since it's a square, the length of each of the sides is going to be x plus 3. And just a reminder that each dimension here, x just stands for the length of each side, and they're all the same. So as it turns out, the perimeter, so you have to figure out what is the perimeter. So if I'm on a square and I start walking on the edges of the square, the total distance I walk following the edges of the square until I get back to my starting point is the perimeter. So the perimeter is just the lengths of each of the sides added up. So the perimeter of the, in this case, the light blue square is equal to 4 times x plus 3. In other words, 4 times x plus 3 is the same as x plus 3 plus x plus 3 plus x plus 3 plus x plus 3. I'm adding the same quantity to itself 4 times, and that's the same as 4x plus 3. That's the perimeter of the new square. But the perimeter of the new square, which is 4x plus 3, is 40 centimeters more than twice the length of each side of the original square. So the is word is a key to write an equal sign. Is translates to equals. So this is the perimeter of the new square, and what is it equal to? Twice the length of each side of the original square. Well, what is the length of each side of the original square? It's just x. So it's 40 plus 2x. It's 40 centimeters more, so that's 40 more than 2x. And lo and behold, I have an equation. And now all I have to do is solve for x. So let's go ahead and solve. 4 times x is 4x. 4 times 3 is 12. Is equal to 40 plus 2x. So what I'm going to do is I'm going to take my 12 and move it over here, and my 2x and move it over there. And that's going to give me 4x. Remember, the price of moving my 2x over is it changes its sign, is equal to 40. The 12 also changes its sign. So that gives me 2x is equal to 40 minus 12, which is equal to 28. So if 2 of something is equal to 28, I find out what one of that something is by dividing both sides by 2. And 2x divided by 2 leaves me a single x. And 28 divided by 2 is 14. And 14 is the length of the original square. So that length is given in centimeters. So my math lab may want you to put in the centimeters. It probably wants you to just enter some number in, like 14. So that was not so hard. So that might be, this is problem example 1, that might be something that you might see on an exam. I realize that online learning is hard, so I'm trying to keep things basic. Here's the next one. So Maria and Eduardo are traveling to a business conference. The trip takes 2 hours for Maria and 2.5 hours for Eduardo because he lives 40 miles further away. Eduardo travels 5 miles per hour faster than Maria. Find their average speed. So the average speed is just that formula I gave you for speed. Speed is equal to distance divided by time, miles per hour, and that means the average speed. If you ever go into calculus, you'll actually try to discover things that are called the instantaneous speed rather than the average speed, and that's really important. Think about SpaceX and all of the launches. They want to find not the average speed, but the speed at a given instant. So our guiding equation, let's first find what they're asking for. Find their average speed. So R is going, that's that rate, which in this case is to be interpreted to speed, is my unknown. That's what I want to know. So that means my guiding equation is going to be R is equal to D over T. So that's going to be an equation I use in some form. So let's write out some data. So let's find out what I'm going to suggest that we do here. If you want, we'll just do it this way. Maria's time the trip takes 2 hours for Maria. And Eduardo's time. We're going to eventually put all of this in a table. Eduardo's time. It takes 2 hours for Maria and 2.5 hours for Eduardo. Because he lives 40 miles further away. So the distance for Eduardo is 40 miles plus Maria's. This is the part I say we were collecting all of the data. Eduardo travels 5 miles faster than Maria. So let's let x equal Maria's speed or rate. So that means Eduardo's speed is equal to x plus 5 because I've decided to let x equal Maria's speed. Now if you wanted to let x equal Eduardo's speed, then it would be x minus 5, and that would be Maria's speed. So let's put all of this together. So here's what I'm going to suggest that we do. We're going to make a table with the person, speed, time, and distance. Because our guiding equation, speed is r, time is t, and d is distance. Because our guiding equation has those three variables. So let's go ahead and begin to make this table. So that hope I've given myself enough room. So the person, one of the people will be Maria. And what is her speed? That's our unknown. And Eduardo, his speed is x plus 5. Now, what is Maria's time? Well, Maria's time is 2 hours. What is Eduardo's time? It's 2.5 hours. So, can I calculate the distance if I know their speed and their time? Sure, right here's my guiding equation. And in this case, I want to find their distance if I know their rate and their time. So, in this case, distance is equal to r times t. So Maria's distance is 2x, and Eduardo's distance is 2.5 times x plus 5. So here we have almost everything needed to complete our equation. So we know that Eduardo's distance, if you think about it, Maria's information is there, Eduardo's information is here, distance, Eduardo's speed is here, Maria's speed is here. The only thing that we've not expressed in this table is Eduardo's speed. But we know that, the only thing that we don't have in the table is Eduardo's distance. But we know that Eduardo's distance is 40 plus Maria's distance. So we've got it, right? Let's go. So Eduardo's distance is given by 2.5 times x 0.5. So this is my guiding equation right now. So Eduardo's distance is 2.5 times x plus 5. And it's equal to 40 plus Maria's distance, 2x. Oh, great. I have an equation, and I can solve for x. And that's exactly what we're going to do. So 2.5 times x is 2.5x. And 2.5 times 5 is equal to 12.5. And that's equal to 40 plus 2x. So what I'm going to do is I'm going to move the 2x over here and the 12.5 over here. So 2.5x, it gives me 2.5x minus 2x is equal to 40 minus 12.5. 2.5x minus 2x is 0.5x. And 40 minus 12.5 is 27.5. So we have to solve for x. So one way to do it is just to divide both sides by 0.5. But there's a better way to do it. I know that 0.5 is equal to 1/2. So 0.5 times x is 1/2 times x. And that's equal to 27.5. So to solve for x now, all I have to do is multiply both sides by 2. Since 2 times 1/2 x gives me x. 2 times 1/2 x is the same as 2 divided by 1/2 x, which is the same as x, is 2 times 27.5, and that's equal to 55. And that's miles per hour. So what was x again? X is Maria's speed. So Eduardo's speed is x plus 5, which is 55 plus 5, which is equal to 60, and this is in miles per hour. So not so bad. It seemed really, really hard, but this is the key right here, is putting down all of your information and transferring it to a table. So let's go to example 2. So a chemist needs a 20% solution of alcohol. She has a 15% solution on hand, as well as a 30% solution. So if she mixes the 15% solution into the 30% solution, that's going to dilute the 30% solution because it's weaker. If she takes the 30% solution and puts it into the 15% solution, she's going to increase the strength, the opposite of dilute. So how many liters of the 15% solution should she add to the 3 liters, which is 30%? Should she add to the 3 liters of the 30% solution to get a 20% solution? So she's going to dilute the 30% solution. So in this case, again, we need to find our guiding equation, and you need to have these equations memorized or on hand. My thought is, for your exam, you're going to be given exams in my math lab, and I will talk to you about knowing or having memorized formulas. So we can so the chemist has 2 solutions, a 15% solution, and then in a larger jar, let's imagine. I mean, my drawing's never good. This is a 30% solution of alcohol. So we need our guiding equation. And this is it. The amount of pure solution is equal to the percent concentration. Another word for that is the strength. It's given in percent times the quantity. And the quantity in this case is liters. So what is she going to do? Let's go back and reread. We had to identify our x. So how many liters of the 15% solution should be added to the 3 liters of the 30% solution to obtain the 20% solution? So our unknown is, our x is going to be liters of what? Of 15% solution. So visually, she's going to be dumping this 15% solution into the 30% solution. And in doing so, it's going to, what's the word I'm looking for? Dilute this 30% solution. How much does she have to dump in there to dilute it down to a 30% solution? So let's make a table. So our table will have strength, and that's just another word for the percent concentration. Imagine if you were working in a hospital and you were getting a saline drip or something, and you were low on saline, and you had a 30%, well, probably not 30% saline, I have no idea, but you can imagine a real life scenario where you might have to do that. It's not going to be alcohol, but maybe something else. And let's have quantity. Let's put quantity. The quantity is going to is given us in liters. That's just given to us in the formula. And our last table item is going to be, where's my line? Is going to be amount, the resulting amount of pure solution. So let's add some things here. I have a 15% concentration, a 30% concentration, and my final concentration I want to be 20%. That's my final concentration. Now, I have a 15%, a 30%, and a 20%. This is what I want right here. Now, we've already decided that our X is liters of 15% solution. And I have, how much do I have of the 30% solution? I have 3 liters. So when I dump my 15% solution into the 30% solution to get my 20% solution, I'm adding whatever amount I'm putting in my 15% jar into the 30% jar, which is already 3 liters. What's my amount of pure solution? Just by the formula, that's 15%, which is 15 over 100, times X. This is 30 over 100 times 3, and this is 20 over 100 times X plus 3. So now we're ready to put things together, and the final result is going to be the following. I'm adding the amount of pure solution to, I'm adding the 15% to the 30%. So that's 15. Let me give some more room up here. I could make it smaller. So our guiding equation is amount of 15% plus the amount of 30% is equal to the final. So that's 15 over 100 times X plus 30 over 100 times 3. So I'm adding these two together, and that gives me this. Is going to be equal to 20 over 100 X plus 3. That looks nasty, doesn't it? But it's not, because what we're going to do to solve our equation for X is just clear the denominators. And the denominators are all the same. So I'm literally going to multiply both sides by 100. The entirety of the left-hand side and the entirety of the right-hand side. When I do so, the denominators cancel out. So that gives me 15 times X, 30 times 3 is 90, is equal to 20 times x plus 3. Again, 15x plus 90 is equal to 20x plus 60. Moving the 60 to the left-hand side and changing its sign. Moving the 15x to the right-hand side and changing its sign. 90 minus 60 is 30. And 20x minus 15x is 5x. I know how much 5x is. I want to know how much x is by itself. So I divide both sides through by 5. 5x divided by 5 gives me an x. 30 divided by 5 gives me 6. So I need to add 6 liters of what? The 15% solution to the 30% solution, and the result will be a 20% solution. So what made this key? The simple thing is, I didn't try to convert these to decimals. I cleared the denominators. Otherwise, I would have had something like 0.15x plus 0.3 times 3 is equal to another decimal. I don't want to deal with that. So much easier just to clear the denominators. Okay, so let's do another problem. So an artist has sold a painting for, oh wow, that's a lot, for $410,000. He invests a portion of the money for 6 months at 2.65% interest, and the rest of the year at 2.91% interest. His broker tells him the two investments will earn a total of $8,761. How much should be invested at each rate to obtain the amount of interest earned? So clearly our guiding equation here is going to be interest. Interest is equal to principal times rate times time. Time is going to be in years. And we've got to decide where our unknown is. Let's let x be the amount invested at 2.65% interest. And once I find the value of x, then I can subtract it from my total amount, and that will give me the amount invested at 2.91% interest. So again, let's make a table. Principal times rate times time, and then your interest. Remember, our interest is equal to I is equal to PRT. So one of my rates, sorry, I don't want that. Don't ever want a freehand if I can help it. So we have two amounts, right? Our first amount that we're going to invest, in this case principal, is going to be the amount invested at 2.56% interest. So that's 2.65% 2.65%. And what is the time it's going to be invested at? It's going to be invested at 6 months, which is the same as 1/2 of a year, because our time has to be in a year. And I is equal to PRT. That gives us 1/2, which is my time, times 2.65%, which is 2.65 over 100. And times our P is our X. And what is the next principle? Well, I have $410,000, and I'm going to invest the rest of it, which is 410 minus the amount I invest at 2.65% at 2.91%. Again, it's also going to be invested at, the rest is going to be invested at 1 year. So again, that's 1 times rate, 2.91 over 100, times our principal is $410,000 minus X. So our interest earned, our interest at rate 1 plus our interest at rate 2 is going to be equal to 8,761. So the equation now is our interest at rate 1 is 1/2 2.65 divided by 100 times X plus my interest at rate 2, which is 2.91 divided by 100 times 410,000 minus X. When I add those two rates together, I get $8,761. So again, we're going to solve this by multiplying both sides through by 100 to clear out the denominators. So literally, I'll put parentheses around this and multiply it by 100. And parentheses around the entire left-hand side, because I'm multiplying the entirety of the left-hand side by 100. And that allows me to cancel out the 100s. So I still get 2.65 divided by 2x plus 2.91 times 410,000 minus x is equal to 8,761, and I add 2 zeros. So it's nasty, especially since you're not supposed to use a calculator. But now what I would do is, notice I still have a 2 in the denominator. I would multiply everything by 2 one more time and solve for x. And I'm literally going to let you do that on your own. And I'm okay with you in this case to use a calculator. Your x, actually I don't have it written down, but go ahead and solve for x and see what you get. And I don't have it written down, and I'm losing time, and I don't want to do it. The numbers get really, really big, and it takes time to do it. But the important part here is the setup. because this can clearly be multiplied. There's no way to make these decimals go away, so we're going to be doing decimal multiplication at some point, and I don't want to do it without a calculator, and I don't want you to actually do it without a calculator, because why? That's what calculators are for, right? So just getting it to this point right here, the sit-up, and multiplying everything through by 2, which you can do if this were something on an exam, would be all I would care about. It probably won't be on an exam. And if you're doing a homework and you see something like that, whip out your calculator. I'm okay with that. That's what they're for. You've got enough on your table to not worry about doing everything in your head. So is that it? Is that it? Is that it? Is that it? Okay, that is it for today's lecture. And I hope it was helpful. If you have questions about anything or you want to check your final answer, I will calculate it right now after it's done and write it down. Just let me know.